Now we start to present uh, chapter 2, configure the static route and the default route. So last topology, and I used the ENSP to present this topology here. So I have configured all the interface. So from R1, uh, show IP interface brief. We have a loopback address 10.0.1.1, and we have a serial port connect to 10.0.12.1, which is here. No, this one looks like interface G000 IP address is 10.0.13.1 255.255.255.0. Okay, so from R1 we should be able to ping the directly connected interface like 10.0.12 is dot 2 is the IP address on R2, this interface. We also can ping 10.0.13, which is this dot 3 here. Okay, so this interface, let's see what happened here. Show brief. So this one is here, but it's down. Let's see here. Display IP interface brief. So okay, so this one is not configured yet. So interface G0000. IP address is 10.0.13.3. 55.255.255.0. So let's try to pin. Doesn't come up. So show still down. Show this interface 0. Oh, Ethernet 000. How that's happened? Interface. Okay, so okay, we better change this. Remove connection. Use 0 to 0. Okay, now it should come up. So basically we can ping the ping 10.0.23.3, which we ping from here to here. So because they are all directly connected, you don't need any routing information. So you can ping here from R1, you can ping here, you can ping for sure, you can ping the loopback, right? So let's verify 10.0.1.1. But let's show the IP routing table. So last routing table, right, is called the forwarding information based. It's basically the routing table. So you can see 10.0.1.0. That's the loopback address. See here. That's the network. That's the address. Um, this one here, these two actually here, 10.0.12.0. That's this network, and it also can see the dot two is the other side. Uh, dot two is here. Also, you can see 10.0.13.01. Uh, that's basically here. This one I think is the Huawei is different from Cisco. You can see if it's the serial interface, you can see actually the remote IP address. But looks like if it's the Ethernet interface, it doesn't learn it. So I assume uh, that's why I mean Huawei is kind of different from Cisco. If it's a Cisco device, you couldn't see this one. You can see only your local interface and also the subnet. This also subnet like those. Okay, so now if you want to ping 10.022, which is the loopback interface on R2, uh, you cannot because this 10.0.22 network is not in your routing table here, so you wouldn't be able to ping. Also, there's another network here, 10.0.23.2 or .3. You shouldn't be able to ping because again, you don't have routing information. Okay, so let's add the static routes. Okay, so now we are on R1. Uh, we want to add this loopback uh, address into our routing table. So is the static route static 10.0.2.0 255.255.255.0. The next hop is the remote IP on this one. So it should be 10.0.12.2. Okay, now display IP routing table. So now you can see 10.0.2.0/24. That's static means the static protocol. Um, Also, there is the preference 60. So by default, the Cisco static route is different from the Huawei. So on Huawei, the direct connected interface, the preference is 0 and the static is 60. On the Cisco router is called the administrative distance. Uh, so you can short to like AD. Sometimes they talk about AD means the administrative distance. That's basically the priority or preference of this route. So their the direct routing is 0 and their static is 1. So what does it mean is to see if you in your routing table you learn uh, two identical routes, uh, exactly the same thing, the same network, same subnet mask, but which one you prefer. So on the Huawei router, the lowest number here is the most how to say the priority has the higher priority. Um, so to say you have two identical routes to some node, but the preferences one is 0, one is the like a 60, right? Not 0. 0 is directly connected. So say you have a static route 60 and you learn something from OSPF. Um, so which number is lower um, is better. You prefer that one. So I will present let me find the default preference from Huawei. Give me 1 second. Okay, so here is the default preference. So you see the directly connected network is 0, OSPF is 10, ISS is 15, static route is 60, RIP is 100, OSPF, that's the AS ex, external is 150, and the BGP is 255, which means uh, if to say have you learn same routes from all these protocols, you will prefer the one you learn from OSPF. Uh, so if the OSPF route for some reason died, you take the one you learn from ISS all the way to BGP. So this one is a little bit different from Cisco. Cisco, the the second highest priority is static. The number is 1. Um, so you can check the Cisco webpage for their information. But that's basically the same idea. On Huawei is called preference. On Cisco is called administrative distance. Okay, so now we have the routes on R1. So what do you think? I think we still cannot ping. We can ping 10.0.2.2. How we can ping it? IP table. Okay, I see. So we have what happened is here. What I'm thinking is to see if you ping 10.0.2.2 and the source pin source IP forwarding. Okay, let me see how I can use source. Okay, so this command you see here is how you specify the source address. Because by default, if you pin the routes, the route by default will use the local interface as the source. In this case, if you pin from here to 10.0.22, in your routing table, the next hop is on this interface. So this router will use 10.0.12.1 as the source address. So that's why you can pin 10.0.2.2 because this one is also the local network on R2. So when the traffic sent to 10.0.22, the respond this router will respond to 10.0.12.1, which is the interface here. And I'm pretty sure on the R2, it does know where to send it. So IP routing. So you see here, 10.0, 10.0.12.1. Okay, let's see the what happened here. So if we ping, we specify the source address, which means I send the ping from 10.0.1.1 to 10.0.22. Yeah, um, the traffic this way can go because you have the route. But when the traffic hit R2, it doesn't know how to send it back. That's why the 5 pins doesn't succeed. So what happened here? So we have to add IP route IP route static 10.0.1.1 255.255.255.0. The next hop address is 10.0.12.1. So when we add this, we should be able to ping it. So now this router knows where I should reply uh, the ping request. So display IP routing table. So from here you can see the this one here. So basically, uh, less the next hop. Here is the next hop address. Less the interface for this route. Now let's try from R1. Let's try to pin this network. So for sure we cannot ping, right? Because we don't have any routes for this, either 2 or 3. So let's add this route. So IP route static 10.0.33.0.255.255.255.0. So in this case, next hop, we either can go this way or we can go this way. So we use this one because this one is the gig interface and this one is the serial interface. So we prefer to use this one. So the next hop is 10.0.13.3, which is the interface here. So now we should be able to ping 10.0.23. Either 2, no, 2 we cannot. Hold on 1 second. Let's pin 3. 3 we should be able to ping it. Yeah, 3 is here, but 2 doesn't know how to. I mean, 2 is here, right? So 2 doesn't know uh, because when you send this traffic by default is coming from here. The source address is here, but from R2, it doesn't know how to reply. So now let's try something very interesting. So I will specify the source 10.0.1.1 and the destination address is 10.0.23.2. So basically we ping from R1 to this interface. So from here, I think the traffic can go this way to this network. And R2 is because the source address is 10.0.11. R2, remember here we have the route. Uh, in this case, we should be able to ping it. Let's see what happened. Okay, but the request will go this way because he knows where it is, this interface, right? So let's see. So R3 know where is 10.0.23. So the traffic will go this way, but the reply will come back this way because from the R2 perspective, right? If we want to send traffic to 10.0.1.0 network, I will send it to here. So now we have a static route from R1 to this network. We send it this way. We also can configure, they call the backup static routes. Let's see how to configure it. Static 10.0.33.0 255.255.255.0. Now I send the traffic this way. So the next hop is 10.0.12.2. By the way, I can see I put the preference before, I mean by default, there's 60, right? We put 61 here. So let's see what's the routing table looks like. You see the 60 is still there, right? Because they prefer use this one here. So even you have the route, display current config. So you can see that's the static route. Uh, so that's the higher priority one. This one is the lower priority. But in the routing table, they just use this one, not this one. But we can test, like if we shut down this interface, this one uh, should delete from the routing table because uh, the next hop interface is no longer available. So let's see, interface G000 shut. We still should be able to ping 10.0.23 dot either 2 or we can ping dot 3. Okay, dot 3 because now dot 3 is this side. This R3 doesn't know how to send traffic back because your default, by default, the source IP address is here. Is here, but this R3 doesn't know anything about this network uh, because the R3 has to know the routing back to the source interface. Um, let's see. Now we shut down the net interface. Show. Now you can see because we shut down this interface here. So even we still have the static route, but the next hop is not available. So it shouldn't in the routing table like here. So compared to the routing table here, you see the next hop is 13.3, but now it's 12.2. But you can see the preference is 61, which is the our backup static route. So let's see the config. So here we still have two static routes to the same network, but the preferred one, the next hop is not available. So the router will not put this static route into the routing table, and it will pick up this one. Another thing you can try is we can trace route. So trace RT 10.0.23.2. You can see it's just one hop away, so which means the next hop is 10.0.12.2. So now we can bring up this interface to see what happened here. So interface G000 undo shut. Okay, if we trace route 10.0.23. We trace to here. Let's see what happened. Because we use this interface as the source, so the R2 doesn't know how to send traffic to here. Let's we see the star here. So Control C to break it. So trace RT, so dash A. So we specify 10.0.1.1 and we trace 10.0.33.2, which is this interface again. Let's see what happened. So 10.0.23.2, 0.3.2. This one have no. Okay, let's ping dash A 10.0.1.1 and 10.0.23.2. Yeah, it should be able to ping. So um, I will let you guys to think about when we trace from here the source address. If you specify the source address as loopback, why we have the stars here. You have to fully understand how the trace route works. So if you know how the trace route works, you should be able to understand why we have to start. So what happened is trace route use the ICMP to record the pass. The first pass is from R1 to R3 because our from the routing table we point go to this network, we go here, right? So they will send us 3 ICMP packets. So these 3 packets got lost. Why? Because when you send the traffic to here, source 10.0.11, this R3 doesn't know where to send the reply back to 10.0.1.1 because R3 doesn't have this routing table. Uh, so the second one, because when you send traffic to here, that's the second, I mean, another 3 SMP packets. When the traffic hit here, R2 does know how to send traffic this way. So that's why you can see the next hop is 23.2. So now we can try to add uh, the static route. So IP route static 10.0.1.1 255.255.5.0 10.0.13.1. Okay, now R3 know how to send traffic this way. So if we try this trace route again, let's ping trace. You see, it should know where to send the traffic. The next, we will present the default route. Default route is kind of how to say the routes, which is the last one. The routing table will be checked. Uh, so what that means is if you display your IP routing table here, every network is specified, which means 10.0.1.0/74. You know exactly what's the subnet it is. And but now to see, I don't have any routes here point to 10.0.33. I can still let's set up a default route. So IP route static 0.0.0.0.0.0. Let's put 10.0.13.3. What does it mean is any network I want send traffic to, but I don't have this specific routes in my routing table, I will use this one. So 0.0.0 means those 0 means everything. Any other routes not in the routing table, I send traffic to 13.3. So let's ping 10.0.3.3. Yeah, now we can ping. Even we don't have the specific routes for 10.0.3.3. Let's see what happened here. So that's the default route we added. To see here, we don't see any traffic, any routes going to 10.0.3.0, but we still can use the default route, and we can send traffic to here because on the R3 it doesn't know how to send traffic back to this interface. That's the local one. So we still can ping dash A means the source route, the source IP. Uh, I think we added the static route point this way. So 10.0.3.3. Yeah, because here we use the static route to send traffic back to IP route. We have static route here. So the default route in this case, uh, we can set up a static default route to send the traffic to help the router to figure out if I don't have those specific subnet in my routing table, I will take the default route. Basically, the default route will be used like for the most common use is for the internet connectivity because um, by default the local network should learn the specific route of any of the subnet in the local network to see we have uh, our company's network. So in this network, we should learn each other's specific routes, but when we want to send traffic to the internet, uh, we don't want to put any specific route because there's hundreds of millions, I mean, half a million, maybe more than that, routing tables, the entities in the routing table. So we don't want our router to learn all this specific route of the internet host or network. Doesn't make any sense because uh, if we have a default route, any traffic go to the internet will send to our internet service provider for sure. And we don't need to know the specific to see who is yahoo.com, who is google.com, right? We just send traffic to our service provider and they will handle the traffic. Um, now we go back to the documentation. They have some questions here. What is the source address of the ping data packets sent from router by default? The default is the interface, the physical interface, which is this interface is the next hop, is connected to your next hop IP address. So see if you send the traffic to here. I mean, in your routing table, if the next hop is here, they use this interface as the source. That's by default. In this lab is connectivity implement for all the network segment. We didn't do that. So what's the simplest static route configuration for this lab topology if only static route are configured to implement connectivity? I think this one we can use the default route. We can specific the next hub address or interface one configure static route. See the difference between the two configurations. How do configure static route? So that's the question about how the Cisco static route. I think Cisco can do the same thing, but I never use the interface myself. I just use the next hub IP address. So let's try on this router to see how they can configure the next, not the IP, but the interface. Okay, so here, um, because this one I think we don't have this 10.0.33. Yeah, we don't have this, so we can try to add the interface, not the next hub IP address for this network. Okay, so IP route static 10.0.3.0 255.255.255.0. The next one is interface. I think the interface is 0001. Okay, let's ping again. Yeah, it works. So when you display the routing table, you should see the next hub is 10.0.23.2. That's the local. You see .2 here? That's the local interface. But you see if you specify the next hop, what's the difference you can see, right? IP. So see here, it's from R1 to R2, right? So 12.2 is here, right? And the serial interface is this one. So, but this one is a little bit different because you specify the interface. No, not this one here, the interface, right? So, but this one is not the next hub. I mean, it's not the remote, it's the local IP address. That's the only difference between uh, the different config. You can use the next hub, or I mean the remote address as the next hop address, or you can use the local physical interface to configure your static route. Okay, let's see. Okay, so from this documentation, they also have the default preference of each routing protocol of Huawei routers. Um, I think on Cisco, the BGP, they have IGP, IBGP, and also eBGP. They have a different AD, which means they have a different preference. Uh, so that's the difference from between Cisco and Huawei. So I think it's good to know. So here it is the Cisco default distance values. So you can see the connected interface is 0, is same as Huawei. Static route is 1, it's different. Huawei is a 60, right? And let's compare. Uh, let's do this. So connected interface 0, 0 is same. Static route Cisco is 1, Huawei is uh, 60. And Cisco have a EIGRP, and so Huawei doesn't have it. Also, they have the BGP is 20, and the IBGP is 200, but Huawei is 255. So to see if it's a Cisco router, if you learn the same route from eBGP, right, it's preferred to some IGP like OSPF. It makes sense, but the Huawei for some reason if you learn the BGP, right, but also you learn something from OSPF, it still prefer the OSPF. Um, it also makes sense because most of the network you will redistribute BGP into OSPF. So locally you see the route as the OSPF, but only on the edge router you see as it is as the BGP. But you have to remember this thing. They may create a loop. But you can change this preferences as well. So we will talk about this later. So OSPF, Cisco have a 110, uh, Huawei have a 10, and ISS have 115. This is 15. So basically, Huawei has if you Cisco minus 100 locus is like a Huawei's preference. RIP is 100. This RIP is 120. This OSPF, you see, the OSPF. Where's the OSPF? They don't have the yeah. So for Cisco, they have all the OSPF. They have the same distance, but uh, I can tell you on the Cisco router, the OSPF have a different routing type. They have an internal, they have an intra area, they have inter area, they have an external area. So uh, they prefer the intra area routes. The second prefer is the inter area routes, and the third one is the external routes. Um, so they have the same, even they have the same distance, administration distance, but from the different routing type, the OSPF pick up the different route. Okay, last little bit for today. So thank you guys to listen.